everyone. So the next presentation is titled Your AI Application Needs Evals, Evaluation-Driven Development in the Era of Prompts. I think it's nice that we are having this presentation right after the previous one, because we're going to talk about how to build LLM applications with proper evaluation framework setup. I'm Uras. I'm an AI engineering tech lead at Monday Campaigns team. And I'm excited to be representing Monday.com here in this presentation. Thank you. So we're going to talk about LLMs a little bit, as most of presentations do these days. And we're going to talk about evaluation-driven development, levels of LLM evaluation, a very brief, short introduction to LangGraph, which is an agent building framework. And then we're going to have a look at a simple, practical example, which is an email writing assistant. Okay, so my talk begins with a statement/question. LLMs are awesome. I mean, I think we've just seen in the previous presentation that LLMs are awesome. But they also, if you let me ask actually, how many of you use the chatbot, like a chat agent or something? Okay, how many of you actually tried to like build an LLM application, like making an API call? Okay, nice. I wondered if you had to write "do not hallucinate" to the prompt to make it. Okay, you didn't. Nice. So the point is, LLMs are awesome, but they are not free lunch. What is a free lunch? It's actually a mathematical theorem. You can look it up. It's called no free lunch theorem. So there isn't a single solution, like a universally applicable solution to every problem. So even though LLMs sound amazing because they let us write, like solve problems using natural language, right? But they still come with their caveats, so they are no free lunch. And I have some examples to back that up. At the left-hand side, this is a chatbot for a Chevrolet dealer in the United States, and it's selling a 2024 Chevy Tahoe for $1, $1 US to the customer. And it's saying, this is a legally binding offer, so no takesies, backsies. You can have this for a single $1. And on the right-hand side, we have Klarna's chatbot teaching the customer how to flatten lists in Python. So this shouldn't happen, right? More serious, a bit more serious examples. So New York City Council's AI chatbot was telling the small businesses, like basically making up information about how small businesses should operate and they should be managed. And the city actually didn't take it down for a while. And this is pretty much recent. Air Canada had to honor a refund policy its chatbot made up. It actually went to court, and the court ruled that the company is responsible for what the chatbot is saying to the customers, right? So yeah, these are some funny and also scary examples, but now, like, what should we do to avoid these headlines, like avoid being the developers that go into these headlines? And yeah, we need to speak about evaluation-driven development. So the motivation here is that most of the software engineers that are delving into developing applications with LLMs, they are actually used to like writing deterministic code, right? So you know, like you write a function, you know that for certain inputs, that function is going to behave deterministically and give you a certain output. But with LLMs, it's a bit more complicated. So for the same inputs, you can get different outputs. So you ask the same question twice to ChatGPT, and based on the question you ask, you will most likely get a different answer each time. So evaluation-driven development helps us make it as less non-deterministic as possible. So we are building applications using natural language with prompting, but we also want to get close to deterministic behavior as possible because we don't want to be on those headlines. Building an AI application requires some data. So these large language models are built on data, and basically we also need lots of inputs, examples like outputs. We basically need a good amount of data. And the assumptions we make when creating these programs, building these these logic, basically the assumptions we make and the production data and edge cases mostly like do not match. So it's sure that you're gonna have problems if you don't have like a good evaluation framework. Before diving into the levels of evaluation, I want to talk about bootstrapping. This is in the context of data. So let's say you are building an agent, a chat agent. Do you have to write many test cases by hand, one by one, manually? No. You can actually go into your favorite LLM like ChatGPT, Gemini, whatever floats your boat. And you can basically ask, give me 20 example prompts for an email writing assistant to be used in testing different scenarios. And then you basically have your first set of data. It may not be perfect, but it's a start, right? So you can actually start writing some tests and building an evaluation framework by using bootstrapping. So you don't have to spend so much time, at least in the beginning, for it. So what are these so-called levels of LLM evaluation? It's basically an approach to divide and conquer the problem. In the lower level, we have unit tests. So these are much like regular unit tests that we write, but for LLM calls. So you have your prompts, you have your functionality, but you want to test, you want to see like when you change things, you're not actually harming really basic behavior. Like you can validate schemas. If you have a retry logic, you can validate, like test that retry logic and so on. So these are fast, simple, small, quick tests that you can run to see if your LLM is still doing its job in the most simplest way. Second level is human evaluation. So this sounds a little bit, I don't know how it sounds, but to me at first it sounded a bit dumb, but just look at the data, right? I can't stress how important it is to just look at the data. So remove all friction from looking at data and basically inspecting the agent outputs, both for development and debugging. Just put it in a JSON, like put it in just build a small UI and see what was the input, what was the output, and why this thing that we don't want happened, right? Third level, model evaluation or automated evaluation. Yes, we are only humans after all, so we need to somehow automate this process for it to scale up. And the way to do that is if you have more easily quantifiable things, you can again kind of take this unit test approach and do it rule-based, or use LLM as a judge, which we will briefly talk about to measure more trickier stuff. And then, of course, if your LLM application somehow made it to production, kudos, then you can also make use of A/B testing. Okay, let's have a practical example, which is an email writing assistant agent. It's a very simple agent. I don't expect to see it in the real world, but I will show you a few code snippets as well, and it's built in LangGraph. I will take this chance to briefly talk about LangGraph. So LangGraph is a library that helps us build AI agents, like LLM applications or AI agents, whatever you want to call them. And it has a Python and JavaScript SDKs. And basically, you represent your business logic as a graph. So you have nodes and you also have edges. These start and end nodes are only there for placeholders, but for our simple email assistant, we have a draft node and a refinement node. Draft node takes in a user request, a prompt, and then generates like a detailed draft about how the email should be, who is, what's its audience and so on. And then refinement node takes the draft and gives us a final email. So both of these nodes are LLM calls. So we have prompt A, prompt B, they have different prompts and they basically call an LLM with the inputs and they get an output from the LLM and pass it on. Another important thing is that we keep a graph-wide state object, and this object can be accessed by any node during execution. So in the beginning, we have this user request, but if you move forward and run the draft node, we are going to get the draft. So this email begins with a casual introduction, hello team, and then moves on to etc., etc. And then we run the refinement node to get the final output. So this is basically adding like a really simple thinking step, like a drafting step before giving us the final output. So this is like basically how LangGraph works, and this is how the graph is built. So these nodes are functions that has the state object as an input, and we literally build a graph, like add node, drafting, and bind this function, add node, refinement, bind this function, and then add edges from start to drafting, drafting to refinement, refinement to end. Here we have the initial state. So we invoke the graph with the initial state, get the results, and return the final email. If you are curious about both of these functions, they just have a prompt, like, and they invoke, like, call the LLM using that prompt. So it's literally like 100 lines to build this simple email writing assistant with LangGraph. Okay, so how about unit tests? Let's say we bootstrapped some data, we generate some test cases. If I go back, you will see this thing in the prompt that says the final email must not exceed 100 words. Keep it concise. How am I ever going to know if the final output will not exceed 100 words or not? I'm just giving like a prompt, and I'm sure you all, when using ChatGPT, you ask something and you got something else, right? So this is where the non-determinism actually hurts you, but it's actually really simple. Just check the minimum maximum word count of the final email. So have some test cases, and just whenever you change something, just run those test cases with this very simple word counter, and check if the emails generated with your test cases fail or not. So instead of using your favorite test library, you are basically using just an LLM call to test this. Right. So a human evaluation, let's go to the next level. Just open up that JSON file, run your agent on them, and look at the output. So it doesn't matter if you're looking for like how lengthy it is, how is the tone, how is the style of the email, and so on. Just look at the data, and this will actually help you in the beginning to spot the common failure modes. So what is going wrong and why is it going wrong? And you can iteratively solve them by, changing your prompts, modifying things, and so on. And this will also lay the groundwork for a ground truth data set. Yeah, just as you can see, a JSON file with the input, user request, and the email output. Just believe me, only by looking at the data, like looking at these inputs and outputs, you can sort out many of the biggest problems without even automated evaluation. But as I said, we are only humans and we cannot do this at scale. So we also need some automated evaluation. And I'm going to give a LLM as a judge example because these things you see here, they are not easily measurable. You simply cannot write a few lines of code or any lines of code to check if if the LLM output adheres with the style and tone of the user request, like the prompt, user's prompt, right? So it's a bit trickier to measure. But we must still somehow measure them and keep our metrics so that we won't have any surprises when this goes to production. Yes, so LLM as a judge. So what can go wrong, right? A non-deterministic LLM is evaluating another non-deterministic LLM. I mean, a lot of things can go wrong, but we still use it because it's really, really helpful at scale for catching edge cases. And also there are some good practices of building it. For example, in here, this is basically the prompt of this style and tone judge, right? So one of a really good practice is writing this prompt in a way that you should be very, very clear about the evaluation criteria. So if you just ask here, okay, just I will give you an email and tell me if it adheres with the style of this, like style and tone in this prompt or not, you're gonna be very disappointed, or you're not gonna be disappointed. It's just gonna give you 100% accuracy. Yeah, it's amazing. It adheres with the style. But if you make it much more like detailed, like give me a score between 0 and 10, and 0 and 0 to 3 means this, 4 to 6 means this and that, and so on, it will do a much better job. So let's see it in an example. We have the request, write a casual and friendly email to the team about implementing Casual Friday starting next month. Keep it light and fun. And this is the generated email, and you know, like a casual, fun, and so on. But I would like to show this sentence. Thanks for keeping things professional where it counts. So the email ends with this sentence. And judgment time. So our LLM judge actually gives this a score of 7. And why is that? Yeah, it is the email is casual, friendly, clear structure, and so on. But the closing line about keeping things professional and the overall phrasing feels slightly formal for a casual Friday message, right? So it actually catches this small nuance and gives us a score of 7. So, you know, you can extend this, change this, improve this. Actually, to make my points even stronger, if this evaluation doesn't align with how you want to evaluate your model, then you should also iteratively prompt engineer your LLM judge, right? So make it so that when you look at the results, you actually agree with its results. Yeah? Okay. Right, so as a summary, I don't know if I'm over time or not, but okay, amazing. So we start by defining our metrics. Like you remember, we are building with an evaluation mindset. We're not gonna just ask Cursor to write prompts for us, build everything, like build the agent and we're done. No, we're gonna start by defining our metrics. We're gonna bootstrap some data to help us build our agents. We're gonna apply the levels of evaluation, unit tests, manual, human evaluation, automated. And most importantly, we will learn from these evals and iterate. So if necessary, we'll go back to the first step. So this way, we'll be able to iterate much faster, and also we won't be making some of the commonly made mistakes. As a bonus slide, observability, monitoring, logging. This is very important when developing production applications, but it's also essential for developing LLM applications. Because if we go back to this LangGraph slide real quick, I think you can use your imagination to kind of see that this can be very complex, right? Like you can build like feedback loops, you can have conditional branching. This graph can be a crazy graph. So you need to like imagine tuning all of these nodes and trying to debug an issue. It's hell. I've done it before. It's really hell. So you can use tools like LangFuse and LangSmith to it's really easily connectable to LangGraph. So you see inputs and outputs of each of your nodes, and this makes it much easier to evaluate and see what you're doing. Okay, so closing words. Even Anthropic is not immune against having gaps in evaluation. Anthropic is the company that builds the cloud models, like Cloud Sonnet and Cloud Opus and so on. And this is a snippet from their blog post from 10 days ago. So basically, they shipped a model, they shipped a newer model to production, but the results, like the outputs got worse. And people actually quickly caught up and like opened support tickets, raised it. And let me summarize this for you. They're saying we didn't have a good enough evaluation framework. So this is their promise to build upon their evals so that they don't ship any model that's worse from the previous one accidentally, right? So yeah, even Anthropic is trying to solve this problem. And yeah, this presentation was inspired by this blog post. Even the titles are almost the same, but I urge you to give it a read if you're interested in this topic. It's really nice. And yeah, that's basically it. If you want to see the job openings, open roles at monday.com, you can scan this QR code and see it. I think it's a tracked QR code, so it will know that you are looking from this event if it helps. But yeah, I thank you so much, and I don't know if we are having questions, but I can take. No, okay, we're not taking any questions. If you have any questions, you can find me. I'll stick around. So thank you for listening.